Hey Tesla fans! Automobile high voltage, welcome to the ultimate hub for everything Tesla. From groundbreaking updates on autopilot and full self-driving, to the latest on Cybertruck, Optimus, Gigafactories, and Elon Musk's bold innovations, we've got it all, right here. If you're passionate about the future of electric vehicles and want to stay ahead of the curve, hit that subscribe button and turn on the bell, because this channel is fully charged with Tesla news, deep dives, and tech breakdowns every week. Let's start our video. Elon Musk has consistently guided Tesla along a path that diverges from the mainstream, creating innovations that stand in stark contrast to those of competitors like Ford, Rivian, or Toyota. This bold vision, initially realized through electric vehicles, now drives Tesla's ambitious humanoid robot, Optimus, into new frontiers. Unlike other robotics firms that prioritize rapid movement or advanced computational abilities, Tesla has chosen a distinctive focus, dedicating over half its engineering efforts to refining the robot's hands. Musk, a visionary with unmatched resources, believes that the hand is the primary conduit for human intelligence. He argues that, across millions of years of evolutionary development, no part of the human body has been more essential. In the earliest stages of human progress, our ancestors relied on their hands to construct monumental structures and perform intricate tasks, long before complex reasoning emerged. This conviction shapes Tesla's strategy to make hands the technological cornerstone of Optimus, particularly in its third-generation model, Gen 3. Musk is confident that these hands, empowered by sophisticated engineering and intelligence, will set Optimus apart, establishing it as the world's most advanced humanoid robot, capable of addressing a vast array of practical tasks. Today's exploration delves into the transformative applications of Optimus Gen 3, from industrial environments to domestic settings, highlighting the pivotal role of its hands. Welcome to Auto Intel. The Optimus Gen 3 hand and forearm, featuring 22 degrees of freedom, has entered early production, demonstrating remarkable capabilities such as catching balls and handling delicate objects with precision. This achievement underscores a fundamental truth: the hand is the cornerstone of human capability. In a remarkably short time, Optimus has evolved from a visionary concept to the forefront of humanoid robotics. Designing a robot that mirrors human manual dexterity demands an extraordinary blend of engineering and functionality. The Gen 3 hand, with its 22 degrees of freedom, represents a significant advancement over the 11 degrees of its predecessor, showcasing Tesla's commitment to practical innovation. The true value of Optimus lies not in its ability to walk or talk but in its capacity to perform meaningful tasks, driven by the unparalleled dexterity of its hands. The human hand, with its 27 degrees of freedom, enables us to undertake any task within our physical reach, from crafting tools to expressing emotions. Equipped with 5 agile fingers, hundreds of sensory nerves, and a complex mechanical structure, the hand is a peerless instrument for creativity, labor, and interaction. Tesla's pursuit of a robotic hand that emulates this versatility has positioned Optimus as a game-changer in both industrial and domestic realms. When Musk announced that Optimus Gen 3's hand achieves 22 degrees of freedom, Tesla ignited widespread anticipation, redefining expectations for humanoid robotics. This milestone is not merely about mechanical prowess but about enabling practical applications that transform how we work and live. Advancing from 11 to 22 degrees of freedom, the hand is now just 5 degrees shy of human capability. To provide context, the 11-degree hand already empowered Optimus to fold clothing, water plants, handle eggs without breaking them, assemble electronic components, transport battery trays, and serve beverages. These accomplishments are only the beginning, as Optimus' manual and cognitive capacities continue to develop. This fuels excitement for the potential of a 22-degree hand in real-world settings. Observing Optimus in action, its gait may not immediately capture attention. Some liken its movements to those of a cautious elder, noting impacts on balance and fluidity. However, when Optimus manipulates objects with its hands, its performance is undeniably impressive. In recent demonstrations, Optimus has caught a tennis ball with pinpoint accuracy, a task requiring exceptional coordination and sensory feedback. The hand's ability to perform such feats stems from its advanced design, which accounts for nearly half the robot's mechanical complexity. In humans, each finger comprises 3 joints and a sophisticated muscular network. Reproducing this in a robotic hand, while maintaining a human-like scale, is a monumental achievement. Tesla's Gen 3 hand, with its 22 degrees of freedom, surpasses other commercial humanoid robots, most of which operate with only 5 or 6. Each finger moves independently, capable of rotation, flexion, twisting, and delicate contact, enabling tasks like typing or dishwashing with precision. The hand's applications in industrial settings are particularly transformative. In manufacturing environments, Optimus Gen 3 is being integrated into production lines, where its hands perform tasks that require both strength and finesse. The robot can pick up minute components, secure screws with exact torque, apply adhesives with consistency, and assemble intricate devices. Its tactile sensors allow it to inspect products for defects, ensuring quality control without human intervention. These capabilities are driven by the hand's ability to adapt to diverse tasks, from handling heavy battery packs to manipulating fragile electronics. The precision of the 22-degree hand enables Optimus to work alongside human employees, enhancing efficiency in factories producing vehicles, electronics, or other goods. This adaptability makes Optimus a versatile asset, capable of transitioning between tasks without extensive retraining, a significant advantage in dynamic industrial settings. Beyond factories, Optimus Gen 3 holds immense potential for domestic applications, where its hands can revolutionize daily life. In households, the robot can perform a wide range of chores, leveraging its dexterity to fold laundry, prepare meals, clean dishes, mop floors, and organize spaces. The hand's tactile sensors ensure it can handle delicate items, such as glassware, without damage, while its strength allows it to carry heavy groceries or move furniture. Optimus can open doors, sort recycling, or even tend to gardens, watering plants with care. These tasks, often time-consuming or repetitive, highlight the robot's ability to free humans from mundane responsibilities, enhancing quality of life. The hand's precision also enables Optimus to assist with more complex domestic tasks, such as assembling furniture or repairing small appliances, making it a versatile household companion. The social applications of Optimus hands are equally compelling. The robot's ability to perform gentle gestures, such as shaking hands, clapping, or offering a comforting touch, opens new possibilities for human-robot interaction. In elder care facilities, Optimus can provide physical support, helping residents with mobility or daily tasks, while its tactile sensors ensure safe, calibrated contact. A soft pat on the hand or a gentle grasp can convey empathy, fostering emotional connections critical in care settings. In educational environments, Optimus can engage with students, using its hands to demonstrate tasks or assist with activities, enhancing learning experiences. The hand's ability to adjust pressure ensures interactions are safe and pleasant, making Optimus suitable for hospitals, rehabilitation centers, or special education programs. These social applications highlight the hand's role in bridging the gap between technology and human connection, a key factor in Optimus' potential to integrate seamlessly into diverse environments. The engineering behind these applications is rooted in the hand's biomimetic design, which mimics human anatomy for optimal performance. Unlike traditional robots that embed motors in the hand, leading to bulky designs, Tesla positions actuators in the forearm, using elastic cables to emulate human tendons. This system allows the hand to be lighter, faster, and more energy efficient, while maintaining precision. The cables incorporate force feedback sensors, enabling the AI to adjust grip strength dynamically, ensuring tasks are performed with the appropriate force. This design enables Optimus to handle a spectrum of tasks, from lifting heavy objects to performing delicate manipulations, without compromising efficiency or safety. The hand's tactile sensing system further enhances its versatility, allowing it to perceive textures, pressures, and temperatures, which is crucial for tasks like cooking or caregiving. Despite these advancements, the deployment of Optimus Gen 3 faces challenges. The hand's complexity requires sophisticated AI to process sensory inputs in real time, which can lead to response delays in dynamic environments. Object recognition remains imperfect, with the robot occasionally struggling to differentiate similar items, impacting task accuracy. Mobility limitations, such as navigating uneven surfaces or high steps, could hinder domestic applications, particularly in cluttered homes. Production challenges also loom, as the hand's specialized components, including high-performance servo motors and rare earth magnets, are difficult to source at scale. These magnets, critical for the hand's compact motors, face supply constraints due to global trade dynamics, potentially delaying widespread deployment. The projected initial cost of Optimus, estimated at around $40,000, reflects these complexities, though Musk has suggested a long-term target of $30,000, which may require years of production optimization to achieve. This price point, comparable to a mid-range vehicle, positions Optimus as a viable investment for households or businesses, provided it can operate reliably for extended periods. Optimus AI includes safety features, monitoring hand movements to prevent excessive force and enabling automatic shutdown if risks are detected. Over-the-air updates ensure continuous improvement, while role-based controls prevent misuse, ensuring the robot remains a tool for productivity rather than harm. Tesla's investment in robotics reflects a broader mission to extend AI from virtual to physical domains, with hands serving as the critical interface. The applications of Optimus Gen 3's hands, from factory floors to living rooms, underscore its potential to redefine labor and interaction. While challenges remain, the robot's ability to perform diverse tasks with human-like dexterity heralds a future where technology seamlessly enhances human environments. What are your thoughts on Optimus' transformative applications? Thank you for joining us, and we look forward to your next visit.